Okay, so let us have the sixth problem in the shearing stress. So for the sixth problem, we have here a setup wherein this timber is fastened by a bolt. This is a bolt and a nut here, and then in between the contact we have what we call washers in between the bolt and the timber. So the dimensions are given here. We have 1/2 inches thick for the head of the bolt, and then 5/8 inches for the thickness of the nut, and then for the certain diameter, the diameter of inside diameter of the washer is 9/8 inches, and then the diameter of the shaft of this bolt is 7/8 inches. 7/8 inches is the overall diameter, including the tooth of this thread. Of course, if this is the shaft of the bolt, this has thread, or this is threaded. Therefore, an additional space for the tooth of the thread is added on 7/8 inches. And then 0.73 is the diameter of the bolt itself. Okay, so if we keep on tightening this bolt here, it will cause a downward force pulling down this bolt. Okay, pulling down this bolt, and at the same time it is stretching the bolt. So what are the stresses now if that is the case? We will have a P here that will cause, number one, sigma 4, or tensile stress for bolt, for the bolt itself, or the trunk of the bolt. What else? The shearing stress at the head of the bolt. So this is similar to the principle of the punching shear, because we have a downward force here, and then at the same time this head of the bolt is restrained, or it is locked at the top. So the tendency here is this is pulling this downwards, so therefore it will cut a hole here at the head of the bolt. Say this is the head of the bolt. So if we pull this down, the trunk will stretch, and at the same time it will cut the head, causing a hole in the head of the bolt. So tau in the head of the bolt. Okay, so this is another stress. So what else? Since we have a contact between the head of the bolt, the nut of the bolt in washer, therefore there will be a bearing stress in washers. Okay, what else? If P is applied, it is pulling this bolt again. What will be the effect on the nut? So on the nut itself, there is a connection between the tooth of this nut to the tooth of the nut and the tooth of the bolt itself. So this is a magnified illustration wherein there is a contact. So if the force exceeded, causing too much stress on the thread or the tooth of the thread, this will be cut. Okay, so basically if this is P could also cause a shearing that is distributed rounding this tooth of the bolt. Say this is V. P is the shearing, or V is the shearing that is surrounding the tooth of the thread on the thickness of the nut. Okay, that is why if that will exceed the allowable shear stress for the tooth, it will cause what we call loose thread. So it will cause loose thread in the bolt. So it will no longer be tightened, or it will no longer be loosened if we have a scenario of a loose thread. Okay, so we have actually 4 stresses. Shall we add the shear stress in the thread? Okay, so 1 2 3 4, so 4 stresses. So we first compute the shearing stress in the head of the bolt and in the threads. So shearing stress in the head of the bolt, just apply the formula. Tau is equal to the shear force all over A. Why P? Because P could also be the shear in the head of the bolt as explained. So that is equivalent to 10.82 kips. So 10.82 kips is initially derived out of the tensile force on the bolt, because we will use the condition in the problem in order to come up with the value of P. So where shall we get that one? We take advantage of the given. Since we have 18 KSI tensile stress given here, therefore we'll just multiply that by the cross section of the bolt itself, that is 7 all over 8, okay, squared. So therefore, manipulating the equation, we come up with 10.82 kips, which will be used on the shearing stress in the head of the bolt. So the shearing stress is 10.80, or shearing force is 10.82 divided by pi d times 1/2, or this is area for the same principle in punching shear, wherein the shear area is equivalent to circumference times thickness. So this is circumference, pi times 7 all over 8 times the thickness 1/2. So therefore, the shearing stress in the head of the bolt is 7.872 KSI. So for shearing stress in the threads, we will use the same shear force, and the shear area is pi d times thickness, similar to this, or circumference times thickness, this time on the thread, root of the thread. So where is root of the thread involved? It is involved in the knot. Okay, so basically we will just consider the space that is occupied by the contact with the knot and the root of the thread. So that is 5/8 in thickness. Now 0.731 is the outer diameter that includes the tooth of the thread. Okay, the tooth of the thread, these two teeths of the thread. So manipulating the equation again, we arrive with 7.538 KSI. So finally, what will be the outside diameter of the washer? So the washer is involved in the contact between the washer and the diameter of the head itself. So therefore, we'll just apply here a bearing formula, bearing stress formula, PL over A for bearing. Okay, so cross multiply, we have sigma bearing times area of the bearing. So again, P here is 10.82. It is being multiplied by 1000 as conversion factor. And then bearing stress is 800. So this is in terms of PSI. In terms of KSI, that is why 10.82 here is being multiplied by 1000 in order to jive with the right side of the equation, wherein 800 is actually what? 800 is actually PSI. So 10.82 here basically was converted to PSI also. So as for the bearing area, this is area of the larger circle less the area of the smaller one. Okay, that is why we have pi all over 4 times d squared. And then this was factored out. This is a common factor. And then we deduct the inner and the outer diameter. So finally, manipulating the equation, of course, this is the square root of this expression. And then we have 4.3 inches as the required outer diameter to satisfy the allowable bearing stress of 800 psi. So I hope this video session will help you. And again, I suggest that you practice more problems. So right after this, please stand by for our activity next week on Monday. We will be having a synchronous activity wherein I think we have to set the time and then set the submission after the deadline. There will be no more acceptance of the activity. So good luck and have more practice this weekend. Thank you.